Welcome back. This is Mr. Hassan's Maths channel. I'm now going to answer question number 5 from the October-November 2023. This is the Statistics 1 paper, paper 5, variant 2 from the Cambridge 9709 exam. And this question here is about normal distribution. It says the heights of a member or of the members of a club are normally distributed with a mean of 166 and a standard deviation of 10. So the heights are such that they are normally distributed with a mean of 166 and a standard deviation of 10. So the variance is 10 squared. Now we've got to find the probability that a randomly chosen member of the club has a height less than 170 centimeters. Okay, so I always like to visualize this by drawing the normal distribution curve. Okay, so the heights are normally distributed. Okay, so it's going to have some sort of a bell shape kind of symmetrical curve. So just do a little sketch of that first. And symmetrical, so somewhere about there would be the median. So the median or the mean is 166. We're trying to find the probability that a randomly chosen person has a height less than 170. So we've got to go to 170, which is slightly bigger than the mean. So somewhere over here would be 170. Right? So we want to find, so that's 170. We have to find the probability that the randomly person chosen has a height less than 170. So we need to find this area over here. Okay, so basically what we need to do is to standardize the 170 score, all right, so that we can use the probability distribution table that we have in our formula sheet. So we know that to standardize a score, which we call the z-score, is equal to the actual score minus the mean over the standard deviation. Okay, so I'll just put it in symbol form here. So it's the score minus the mean. The mean is mu over the standard deviation, which is sigma. So we can say the z-score that we're looking for, so we want to find the probability. What we're looking for is that the probability that the height is less than 170 centimeters. So that's the same as the probability that z is less than, and then we're going to standardize the score. We have the score, which is 170, minus the mean, which is 166, over the standard deviation, which is 10. Okay, so we can say that that's equal to the probability that z is less than, that's going to be 4 over 10, 0.4. So we're going to find the probability that z is less than 0.4. So we're going to go to our table. So this is the value for h, this is the value for z. We want to find what this area is, such that the probability that z is less than 0.4. So we have to concentrate on the 0.4 and go to our table, and we look for the probability that z is less than 0.4. Okay, here's 0.4. So we go to z equals 0.4, which is over here. So 0.40, so it's going to be this value over here. Okay, so it's 0.6554. Okay, so that's going to be our answer. So it's going to be 0.6554. So we can therefore say to 3SF the probability that our height is less than 170 centimeters is equal to 0.655 to 3SF. So there's the answer to part A of this question. All right, now for part 2, part 1, that's A part 1. Part 2, it says, given that 40% of the members have heights greater than 8 centimeters. Remember, so the heights are such that they're normally distributed with a mean of 166 and a variance of 100, or 10 squared. Okay, so given that 40% of the members have heights greater than 8 centimeters, find the value of h correct to two decimal places. So now we're going to do the same thing again. We're going to draw our normal distribution curve. Okay, so I'll draw the normal distribution curve over here. Symmetrical. And here we have the mean. Okay, so we want to find that we know that 40% of the members have heights greater than 8 centimeters. So 40% of the members have to have a height greater than that. So we know that our Z value is going to be somewhere over here. It's going to be somewhere positive, right? Because the number of people bigger than that value is less than half of it. Remember that the whole area of this curve is 1. Okay, so if you want to find that the area to the right of a certain value is 0.4, that means that the area has to be less than half the area. Okay, if it said find the probability that 60% of the members have a height greater than h, then the h would have to be here, such that more than 50% of the area would be to the right of it. Okay, so we know that this value here, this h value that we're trying to find, is going to definitely be something which is positive. The z value for this will be positive. It will be bigger than the mean. It definitely has to be greater than the mean. And we know the mean is 166. And in terms of z, this is 0, of course. And this is, I'm going to call it z1. Okay, that's what we have to find. We have to find that what z1 is. Okay, and then once we find what z1 is, we can use the standardization. We know that z equals x minus mu over the standard deviation. If I can find the value of z, I know what the mean is, I know what the standard deviation is. I can find therefore the score for which this will be true. So I need to find what this value of z is. Now, the formula sheet that we have, it gives us the value of z such that the area to the left of it is what's given in the table. Okay, the area to the left of the probability to the left of it, that area to the left of it is what's given in this table. So these z values that we have here, these z values, these are the areas to the left of those z values. So I have to think about the area to the left of this line here. So if this is 0.4, then this part is going to be 0.6. Okay, so I've got to find the probability, okay, that our z value, which is less than z1, is equal to 0.6. I'm going to find the value of z1 for that. Okay, so I've got to go to my table of values and I've got to look for the area. So I'm now looking at the areas. The areas are the values given inside the table. This is the z value, these are the areas. So I've got to find the z value, which is such that 60% of the area is to the left of it. Okay, so I've got to look for the closest I can find to 0.6 in this table. Now, if we look at this table here, we got 0.5987 and then we got 0.6026. Now this looks closer to 0.6 and I can get even closer by adding these values. So if I take this value over here, okay, and I take this 12 to add to the end of this, this will be 0.5999 because 87 plus 12 is 99. So this is going to be combined, give me the closest possible value. Okay, so what is the z value that corresponds to this 0.5999? Well, it's going to be 0.253. 0.253. Okay, so we can see we've got is equal to 0.5999. Okay, 5999. 99, that's right. Okay, and we know that the z value that we're looking for is 0.253. 0.253, and we know it's positive because it's on this side. So I'm going to now, I know that value of z is 0.253. So I can say that this value here is 0.253 from looking at our tables, because 60% of the area is to the left of it. So if I know that z1 equals 0.253, I can now use my standardization. I can say 0.253 is equal to x, which I'm trying to find, minus the mean, which is 166, over the standard deviation, which is 10. So I just simply have to multiply this by 10 and add 166. So x is equal to 166 plus 10 times 0.253. So that's going to be basically 168.53. And it says correct to 2 decimal places. So there we have the answer. So we can say that H is equal to, you can call this H from here actually. Okay, so this was H. So H is equal to 168.53. Okay, so there we have the answer to this question. It says 8 centimeters. So we just write down H as a number because the centimeters is assigned to it there. And there we have the answer to this question. And that's 5 part A done. And 5 part B is on the next page. So 5 part B, it says a random variable X is such that it's normally distributed with a mean of mu and a standard deviation of sigma. So this is the variance here. And we know that the sigma is equal to 2/3 of mu. Okay, so this is not related to part A at all. It's totally separate. And we want to find the probability that the random chosen value of X is positive. So we're going to find the probability that X is greater than 0. Positive means greater than 0. Okay, so we can standardize the score of 0. So the probability that Z is greater than. So if we standardize the score, remember we have X minus the mean over the standard deviation. So the probability that X is greater than, well, X, if we standardize 0, it's going to be 0 minus the mean over the standard deviation. Now the standard deviation is 2/3 mu. So this is over 2/3 of mu. Okay. So this is equal to the probability that Z is greater than, that's going to be negative. And you have mu over 2/3 mu, the mu's cancel out. And you're going to have 1 over 2/3 is 3 over 2, it's minus 1.5. This is like 1 over 2/3. These cancel out, that 0 is just 0 anyway. And so you got 1 over 2/3, the reciprocal of 2/3 is 3 over 2, which is 1.5, sorry. So you have minus Z is greater than minus 1.5. So we simply have to now think about our table of values. Here we have a negative Z value. All right, so it's less than the mean. Okay, so if we think about our normal distribution curve, this would be the mean. Okay, and we're going to be at minus 1.5. So 1.5 standard deviation is below the mean. Minus 1.5. Okay, which is going to be, we want to find the probability of this. Now our table of values only goes from 0, it doesn't go to the negative values of Z. So we have to use some sort of symmetry. So I know that there will be a value of Z which is 1.5, which is going to be in a place which makes it symmetrical to this value over here. So somewhere over there, there will be a value of Z which is 1.5. Okay, and I know that the probability that Z is greater than 1.5 is the same probability because of the symmetry of this. If I flip the area around, you'll get this area over here up to there. It will be the same that the probability of Z being less than 1.5. All right, and that's what I can read from my table. Okay, so if I go back to the table of values, okay, I can look for Z being 1.5. Right, so I'm looking for basically this area over here. So I go down to 1.5. And I see over here as 1.50, so it's going to be 0.9332. So that's going to be the answer there, 0.9332. Okay, so the answer to this question is going to be the probability that X is greater than 0 is equal to 0.933. We'll write it to 3SF. We know that this area here is 0.9332. So we'll keep it to 3SF. And there's the answer. Does it say 3SF? It doesn't say anything, so we leave it to 3SF. Okay, so there's the answer to part B. And that concludes this normal distribution question here from this paper. Other questions from this paper you'll find in the playlist, which will be linked at the top of the video, at the top of the page at the end of the video. Other questions from normal distribution from my S1 collection of Cambridge will be over here. You can subscribe to my channel by clicking on this link, and the video here will tell you how to use my channel to find things you might be interested in. Thank you for watching and see you soon.